It takes its time.
Well, I have the facial hair, but not the musical skills of ZZ Top. Welcome back for day two. Yesterday was a very exciting day. I think we all saw evidence that the work that we're doing together here is fundamentally changing the way the industry works. Yesterday, you saw everything from new prominent members like Microsoft joining the foundation, tons of technology contributions, all kinds of pretty awesome news. I was walking around yesterday. The engineering workshops were packed with the real work of the project moving forward. We had executive sessions back here where there was a lot of new ideas shared. The expo hall was really lit up last night with the cocktail party. A lot of cool eye candy on display for all of us that love hardware. The hackathon, I was here until about 11 o'clock last night. There were still people hacking away at the hackathon. We're going to hear from them later today. I heard that one of the hackathon teams went until about 4 a.m. They've got some significant stamina. So pretty awesome. And it's really awesome to see so many people coming back here on day two. This is a two-day event. We're still experimenting with kind of the flow of the event and how things work from day one to day two. We've got a lot of engineering workshops coming up this year. We've got another summit that we'll be planning for next year, obviously. We've got a great lineup of speakers again for this morning. The first speaker is Mr. Ian Drew from ARM. So Ian, come on up.
Hey, Frank.
Thanks for joining.
No problem. Hi, my name's Ian Drew from ARM. My title, I'm Chief Marketing Officer, Executive Vice President, and I promise you I won't talk to you about marketing at all. I happen to also be responsible for all of the servers that are being developed on ARM. I run all the software. I run all of the community stuff that goes around it. So I really want to talk to you today about what ARM is doing in this space and how the next 5 years is really going to be a revolution in the data center. And it's going to be done not by monolithic structures, but by collaboration, working together, innovation, and really some cool and unique things. I'm an engineer. I started off designing CPUs for a living, so I have to get my head around numbers in some fairly creative ways. I started in the PC industry, and I knew roughly how many PCs there were, and I could count hundreds of millions. I could count billions of phones, and I could go, that's one for everybody on the planet. How do you then go and look at some of the data explosion? How do you get your head around this huge mobile explosion that's going on, and how do you put that into certain numbers? So I looked at this, and we looked at what's gone on over the last few years, where we are at the moment, and what's really driving this data explosion. And we saw mobile and phones really as some of the unique ways in which it's driving this. And so the number that came to mind was how many grains of sand there are on this planet. 7.5 exabytes of sand on this planet. And in 3 years' time, there'll be more exabytes of data per month coming from mobile than there are individual grains of sand on this planet. Huge amount of data that's going to come through. But interestingly, that's not the only thing that's going through a data center. We are seeing huge revolution of data. It's not the monolithic structures that we've seen in the past. It's coming from set-top boxes and DTVs. It's coming from those cat videos that we've seen, everybody's seen across the internet. It's coming from the 500 million of wearable medical devices. It's coming from the Internet of Things, and it's coming from cars and everything else that's connected. And worryingly for some of us, some people are predicting that over 60% of the cars that we're going to ship in the next few years will be Wi-Fi connected. And it worries me what my kids are going to go do in the car rather than just play now. So all of this data is going to come, and it's not going to go through standard devices like laptops, which do processing locally. A lot of that data is going to go through back-end servers and data centers, and it's going to be new structures that we're seeing. But also we're seeing this huge growth in the Internet of Things, how we see the software, how those little bits of data become big bits of data. The growth of all of those connected devices, the motors, the robots, the printers that we've seen lots of hype about, we'll forget about that term Internet of Things in the next few years because they'll all be connected. But more interesting, they'll be connected wirelessly back through into a server farm somewhere. And we need to figure out how to connect them together on the right-hand side and the left-hand side, how this big data and little data come together. And the third change will happen is the way that apps are structured. The first billion apps were games and news apps. What's going to go in future will be apps that are connected seamlessly to the internet, and you won't know that they're connected. You will see just a live application in front of you. And how all of that fits together will be needed to be structured in some of this new revolution in the data center. The second thing that needs to come together is standards. And I like to give an example of standards of the typewriter. The QWERTY keyboard has been around for about 150 years. I'm old enough to remember typing my first thesis for my master's degree on an Olivetti typewriter. If you look at the QWERTY keyboard, it was designed so keys didn't stick. You didn't put two vowels next to each other because if you pressed them together, the keys would stick. If you look at keyboards now, on your touch screens, on your phones, it still has that same QWERTY keyboard. That has really driven a standard that everybody knows, everybody can use. The data center will be driven by a standard as well. We're going to see a lot more efficiency driven through the data center, and there's going to be a few things that will change. We've seen the networking and enterprise becoming a lot closer to data centers. We'll see that moving into the data center and starting to merge. We'll see monolithic structures breaking down as the cloud becomes real. And what we're really looking for is the throughput from the data center. These devices that enable you to connect to the edge, to have data going through the data center much more efficiently, and then workload optimization, having the right size of processing element and the right type of processing element for the job that's required, because it will be efficiently and effectively what's going to drive your total cost of ownership. With the amount of data going through this data center growing exponentially from all of these devices, your total cost of ownership will be driven effectively by how you handle the workload, make it the most efficient possible, and how you handle that throughput, getting the right data in and out in the right time frame with the right quality of service and in the right time frame. All that done in a power efficient way. And we see this as a 5-year revolution. We see the data center today being somewhat monolithic. As the cloud develops, you'll see those elements break down, having smaller processing units, much more efficient processing units, especially near the edge. And then as you move further forward over 5 years, totally heterogeneous designs of data center coming out, focused on scale up, scale out, and total cost of ownership. Frank and I have debated for a long time, and I want to give him some congratulations on this, because when we talked 2 or 3 years ago, he said something to me that stuck, and we'll go into how we've used it. He said, end gratuitous differentiation. What he really meant was, don't differentiate for differentiation's type. Work as a total ecosystem to make sure that if you're adding value and differentiating, the whole ecosystem can make use of that. And he used an example of a timer in an SoC. And he said, why is there so many different timers in so many different chips when they're effectively doing the same thing? And that the software guys have to write drivers for each of these, and then the hardware guys have to have different SKUs for all of these, and then the apps guys have to understand how that works. We needed to go fix that, and we needed to go fix that in a time frame that allows this ecosystem to develop and for data systems to develop. The innovation comes from partnership. And so the ARM business model is around partnership, and we got a group of people together a few months ago, and here's the list of them, and we put that challenge to them. We said, how do you drive innovation? How do you drive differentiation, but still keep the standards in place that make the OEMs and the software community successful? And you know, when you get a group of people together, you quite often have to bash a few heads. And so we bashed a few heads, and we had a few screaming phone calls, and then we met again, and we targeted what was really important about this ecosystem. How do you set standards? How do you have cross-platform portability? And how do you simplify some of the manageability? And for ARM and its ecosystem partners, this was a necessity to go do to drive that next 5-year vision. Because without it, we would have a tremendous problem. And that problem would be that you would have multiple semiconductor companies having multiple different operating systems through multiple different application guys, and we would stifle innovation because everybody would have to do multiple different timers and multiple different memory controllers. For ARM and its ecosystem, it needed to be fixed, and it needed to be fixed now. So I'm really pleased to announce today you can go download now from the ARM website something that we've catchily named Server-Based System Architectural Specification. This was put in place so we can standardize. We can have one single image of an operating system across all ARM v8 servers. This means application guys, you write it once. OS guys, you write it once. For ARM, the ecosystem can innovate in areas that are important to the ecosystem, not at the microcontroller level or the SoC level. This is a hardware spec for OS and firmware developers that is available on our website as of now. It covers firmware, kernel, hypervisor, operating system, but it is not a software spec. It is a hardware specification that was written by hardware guys and software guys together, with the thought that this new data center revolution is happening, where you will get different types of components in a system. Heterogeneous computing, where you use different size computing platforms, be it graphics, be it a CPU, be it a DSP. How do you identify those? How do you make best use of those? This is not a standardization where everybody will be monolithic. It's a standardization where differentiation happens at the right layer, in the right time, so the industry doesn't waste time replicating everything because somebody said differentiation at a low level works. We want to make sure that this gets in everybody's hands, so we've released it today on the ARM website. It covers operating systems from Linux through Microsoft. It has support from OEMs, and it has support from a number of semiconductor partners as well. This is a specification which will drive a vision of change and revolution over the next few years. The start of the revolution is here. The start of the change is here. And I see the next 5 years not as a standard growth, but as a huge growth in this industry that will lead to huge new opportunities to differentiate amongst the whole of that software community. It was done so the apps guys don't have to sit there and go, I need to port this 17 times. You port it once. It works across the full 64-bit architecture for ARM. I think there are 3 things that I see in the industry. This big data revolution is coming. You heard yesterday about how many people are using the phones. There are billions and billions and billions of IoT devices going to coming out there. There is millions and hundreds of millions of wearables. The cars, the televisions, the connected devices. There's a huge slew of differentiated data. The new business model is to get ready for that. As software guys, as server guys, you need to have a model where one size does not fit all. Innovation is important. It's important to scalability, and the business model around that is not proprietary. It's working together. That is the 21st century business model. Scalability by collaboration, not by one person in the industry going, this is the way that it will be. I think innovation at the right layer is also important. And the SBSA accelerates that deployment, accelerates the software community, and takes away the roadblocks to really stopping this industry growing. Because I believe in the next 5 years, this ARM data center, ARM server revolution is happening. And I think with the 3 things that we've talked about today, you now have an industry that can grow. You have an industry that is capable of delivering what the consumers want. And more interestingly, new business models that you can go and grow and make more money from. From ARM, we think this is very important. But more interestingly, the ARM ecosystem and the people who we worked with have put a lot of time and effort into really coming together, not just as one vertical, but a group of companies really revolutionizing this industry. And that is what this 21st century business model is about. Revolution based on collaboration. And really that's what some of this OCP is about as well. So with that, I'd like to urge you really to go download the SBSA. Think about how you port all your software over now, and welcome to this revolution of the ARM-based server, because the next 5 years is going to be great fun. With that, thank you very much indeed.